artificial intelligence, it can be a really powerful approach to extract patterns from high-dimensional data that may be predictive of clinical characteristics such as diagnosis or treatment response. And that can be very useful if these individual elements in the data are not really sufficiently predictive in isolation. So then we can use artificial intelligence as an approach to combine them into models that have higher accuracy, and then these might be useful for clinical application. So in psychiatry, these AI tools are still really much used in the research phase at the moment. But one of the really interesting approaches is to use them for integrating different data types, such as, for example, neuroimaging or genetics data, which could then allow us to learn more about the biology of mental illness and then really use this as a basis for the development of novel clinical applications. So one of these approaches that is used for this purpose is this so-called deep learning, which is an approach that can extract meaning, for example, from freely written text, but also from speech or from medical notes. And that can be a basis for really interesting future clinical applications. Yeah, one of the core challenges in psychiatry is that psychiatric disorders, they're really very heterogeneous, both clinically, but also biologically. So that means that it's very difficult, even using AI, to identify these patterns in the data that are sufficiently predictive to be clinically useful, but also that can then also be prospectively validated. So a particularly interesting application area in AI is therefore to really decipher this heterogeneity and perhaps identify patient subgroups that are affected by specific biological mechanisms. Another really important challenge relates to the complexity of the algorithms, because for models to be predictive, they have to combine really large feature numbers. And this makes them more difficult to interpret, which is important for clinical use. A higher complexity makes also models more difficult to be really reproducible and to be effectively used in the clinic, because they are more costly, there's a higher logistics efforts, and there's also an increased burden for patients. So therefore, the future developments in AI, I think they really have to balance predictive performance with model complexity and have a strong focus on explainability and reproducibility, which is particularly important for these very recent developments, such as chatbots based on deep learning models. And finally, of course, there are also important ethical and legal considerations, because besides this accuracy and reproducibility of the models, the explainability is really one of these considerations, as it affects the ability for shared decision-making between medical experts and patients, so that can protect the autonomy of patients. And closely related to this is also the literacy of really the involved stakeholders to be able to interpret the output of these models. And that makes a participatory approach that includes all the stakeholders during the development of the AI tools really essential for future developments.